Very good morning to all of you children. Today we will discuss or we will revise the next topic of chapter motion, that is rate of change of velocity. The last class we have discussed about uniform and non-uniform motion, and as you know, in uniform motion the object covers equal distances in equal interval of time. It means the velocity remains constant during uniform motion because object covers equal distances in equal interval of time. Whatever be the time intervals, it may be big or small, but distances covered are equal, so the velocity of object is constant. It is fixed in case of uniform motion. But generally we perform non-uniform motion, and as you know, in case of non-uniform motion the object covers unequal distances in equal interval of time. So it has different values at different intervals of time. So velocity is not fixed. It means velocity changing with respect to time. At different point during the movement, during the path of the moving object, the velocity is not fixed. So thus the change in velocity of object during any time interval is not zero. In uniform motion it is zero. The rate of change of velocity with respect to time in case of uniform motion is zero, but in case of non-uniform motion this change in velocity with respect to time is not zero. Now how to measure this rate of change of velocity? So we have to introduce a new physical quantity for it, and that quantity is called acceleration. So as you know, acceleration is equal to change in velocity by time or time taken. So if the velocity of an object, suppose the velocity of an object changes from u to v, it means let initial velocity is u, final velocity is v, then change in velocity is v minus u. Let the time interval is t. Suppose an object is moving so that its initial velocity is u, its final velocity is v, then change in velocity is v minus u, and let this change in velocity takes place in a time interval t. Then for acceleration we can write then acceleration a is equal to v minus u by t. So for acceleration symbol, as you know, is small a. So this is again an important formula to find out acceleration, and difference of two velocity will be velocity. So we can say that acceleration is equal to change in velocity by time, and hence is SI unit. SI unit. As you know, for velocity unit is meter per second, and for time it is second. So it will be meter by second into second. So meter by second square, or this can be written as ms to the power minus 2, or we can write meter per second square. So in this way we are getting unit for acceleration. Now, acceleration SI unit is meter per second square. We are revising. I think most of the students knows these things, but those who have not attentive in the beginning must remember what the definition of acceleration is, what is the formula to calculate acceleration, what is its SI unit. Now, acceleration may be uniform or non-uniform. So, how we can define uniform acceleration? I am reading the last paragraph, page 103 of NCERT book, left side last paragraph, that if an object travels in a straight line and its velocity increases or decreases by equal amounts in equal interval of time, then acceleration of object is said to be uniform. So if the velocity increases or decreases, it means change in velocity is uniform with respect to time, then acceleration is also uniform. The motion of a freely falling body is an example of uniformly accelerated motion. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. It means change in velocity is not fixed with respect to time. It is different at different intervals of time. Then acceleration is not uniform. It is called non-uniform acceleration. For example, if a car traveling along a straight road increases its speed by unequal amounts in equal interval of time, then the car is said to be moving with non-uniform acceleration. So these two terms are then equally important. You must know the definition of these terms: uniform acceleration and non-uniform acceleration. For uniform acceleration, those who have not written it right, if an object changes its velocity by equal amount in equal intervals of time, then it is said to be moving with uniform acceleration. Similarly, you can write the definition for non-uniform acceleration, that if change in velocity with respect to time is not uniform, it is not fixed with respect to time, then acceleration is said to be non-uniform. Now we will discuss some of the questions given on page 103 of NCERT book. So first question is, I think, the definition of these two terms. When will you say a body is in uniform acceleration? So I think you can write the answer. The body is said to be in uniform acceleration if its velocity increases or decreases by equal amount in equal interval of time. Similarly, you can define for non-uniform acceleration, the body is said to be in non-uniform acceleration if its velocity changes by unequal amount, increases or decreases by unequal amount in equal interval of time. So you must write the definition of these two terms, very important terms. And then question number 2 is a numerical, page 103. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. So U is given 80 km per hour. Whenever you have to solve the numericals, you must read the question carefully, write down the given things with their symbols. For example, your initial speed or velocity is given 80 km per hour and final velocity is 60 km per hour, and this change in velocity takes place in how much time? In 5 seconds. So these are the given things, and you have to calculate acceleration. So time is in second, and these two velocities are not in SI unit. So first convert it into SI unit. So whenever you have to convert kilometer per hour into meter per second, you multiply it with the number 5 by 18 meter per second. So if you will multiply, so 2 9 and 40, so it will be 200 by 9 meter per second. Similarly, convert 60 km per hour into meter per second. So it will be 150 by 9 meter per second. Now, we know that acceleration is equal to t minus u by t. So g is how much? 150 by 9. U is 200 by 9. Substitute the values in formula, and time is 5 seconds. So this can be written as, obviously LCM is 9. So it will be 150 minus 200 by 5. So it will be minus 50 by 9, and the denominator as 0, 1 is hidden, so it can be written as 1 upon 5. So cut it will be minus 10 by 9 meter per second square. It means acceleration is negative, isn't it? The velocity is decreasing with respect to time because initial velocity is more than the final velocity. So perhaps brakes are applied, that's why velocity is decreasing. So acceleration is 10 by 9 meter per second square. When we say retardation, then it will be 10 by 9 meter per second square. When we write acceleration, then you have to give a minus sign, that it will be minus 10 by 9 meter per second square. Now the third question. So here acceleration is negative, children. Acceleration may be positive, it may be negative. Positive when you increase the speed of your bike with respect to time, then it will be positive. When you apply brake, it means you are decreasing the speed with respect to time, then acceleration is negative. So negative acceleration is also known as deceleration or retardation. Now question number 3. A train is starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. A train is starting from a railway station. So initially the train was at rest. You have to read the question carefully. Train is starting from the railway station. So initially the train was at rest and moving with a uniform acceleration, and then it attains a speed of 40 km per hour. So he is given 40 kilometer per hour. Generally students write u is equal to 40 kilometer per hour. So if you will write u is equal to 40 kilometer per hour, then it is wrong. And time is given 10 minutes. You have to calculate acceleration. So convert these quantities into SI unit. So 40 kilometer per hour, so 40 into 5 by 18 meter per second. So if you will cut it, it will be 920. So 100 by 9 meter per second. Then time is 10 minutes, so 10 into 60. Convert it into seconds, so 600 seconds. Now acceleration is equal to v minus u by t. So it will be 100 by 9 minus 0 by 600. So it will be 100 by 9 into 1 by 600. So 0 cancel. So it will be 1 by 54 meter per second square. So in this way you have to solve the questions. I think the calculation is clear to you. 100 minus 9 by 0, it will be 100 by 9 divided by 600. In previous question, as we have discussed, in denominator 1 is hidden, so when it is goes up, it will be into 1 by 600. So you will get 1 by 54. Now next question is this much in this topic. Then we have to discuss another important topic, that is graphical representation of motion. Very important topic, graphical representation of motion. It means we can express or we can explain different type of motion, or we can represent different motions with the help of graph. I am reading the first paragraph, left side, page 104. You also concentrate and go through the lines. Graphs provide a convenient method to present basic information about a variety of events. For example, in a telecast of one-day cricket match, vertical bar graphs show the run rate of a team in each over, as you have studied in mathematics. A straight line graph helps in solving a linear equation having two variables. So I think you are familiar with this topic of mathematics, that how we are solving linear equations with the help of graph. Now to describe the motion of an object, we can use line graph. In this case, line graph showed dependence of one physical quantity such as distance or velocity on another quantity such as time. So first of all, we will discuss the simplest type of graph. Whenever we are talking about motion, any type of motion, what are the two things that are changing with time? What are the two variable things? We can say that with respect to time, the distance is changing, isn't it? When an object is moving, it is in motion, it has some speed. The things which are changing are its position and time. So, or we can say it covers different distances in or with respect to time. So, first simplest graph is distance time graph. Distance time graph. So first we will discuss when object is moving with uniform speed. Distance time graph when object is first when object is moving with uniform speed. So as you know, when object is moving with uniform speed, it covers equal distances in equal interval of time. For example, a table is given in your book, table 8.1. You see on page 100, they represent the distance travelled by object A after every 15 minutes. So you see at 9:30 10 meter, 9:45 20 meter, 10 am 30 meters. So if you take this data to draw a distance time graph, we are taking the data from table 8.1 page 100. So whenever you have to draw a graph, table is like this at 9:30 am. Distance cover is 10 meter. 9:45 am. Distance cover is 20 meter. At 10 am. Distance covered is 30 meter. 10:15 am 40 meter. 10:30 am 50 meter. And 10:45 am 16. Suppose this is the distances covered by an object, and these are the time intervals. And suppose this is the data, and you have to draw a graph by taking these. So whenever you have to draw a graph, you always take time on x-axis, because time is an independent quantity. Time is independent quantity, and independent quantity is always along x-axis. So always take time on x-axis, and distance we will take on y-axis. So mark the time, because this is 0, 9:30, 9:45, and then 10 am, and then 10:15. 15 f, then 10:30, then 10:45, like this. Similarly, take distances on y-axis. So 10, 20, 30, 40, 50. So on x-axis I have taken time at different 9:30 am. It has covered a distance of 10 meter. So how to draw a graph? Mark these 2 points. So this is the point. At 9:30 it has covered a distance of 10 meter. At 9:45, 20. So 9:45. So this is the point for 9:45. Again at 10 am 30. So in this way you have to draw a graph. And if you join all the points, you will find, if you will, in this way you find out all the points, and if you will join these points, you will get a straight line. So in this way it is difficult to draw without a scale a straight line in a whiteboard. But if you will take this data and in your copy with a scale, you take these distances, equal distances, and you will draw a graph, you will get a straight line graph. So what it shows, that whenever an object moves with uniform velocity or uniform speed, its motion is uniform, you will get a straight line graph. Now, is there any use of this graph? Why we are drawing these graphs? What we can calculate from this graph? Distance time graph. So, as we know, the speed is a ratio of distance and time. So, with the help of this time, you can calculate speed, because speed is equal to distance by time. So we have taken distance on y-axis and time on x-axis. So if you have to calculate speed in a particular time interval, then with the help of this graph you can calculate the speed in that interval of time. For example, suppose you have to calculate speed between these 2 points. Suppose this point is A and this point is B. So you have to calculate speed between points A and B. Then you have to draw perpendiculars from these 2 points on x-axis, isn't it? You can mark it as T1 and T2, and you have to draw perpendicular on y-axis also. You can mark these distances as S1 and S2, isn't it? So if you have to calculate speed from A to B, then speed will be how much? Speed will be simply S2 minus S1 by T2 minus T1. So S2 is how much? 30. S1 is 20 and T2 minus T1. So 10 am minus 9:45 am. So you will get 15 minutes. Time is in minutes. If you want to convert it into second, so 15 into 6. So 900 seconds. So speed is 1 by 90 meter per second. So in this way, with the help of this graph, you can calculate the speed of an object in a particular time interval, isn't it? So speed is equal to actually between a BC by AC. If you have to calculate speed between points A and B, it will be equal to BC by AC. What BC represents? BC represents the distance and AC represents the time interval. In this time interval, distance travelled by object is from B to C, so it will be 10 meter and this time interval is 15. So this is the way you can calculate the speed of an object with the help of this graph. So first use of this graph is we can calculate the speed of an object with the help of distance time graph. So you write this line. In use you write we can calculate speed of an object with the help of distance time graph. Now this graph was when object is moving with uniform speed. What will happen if object will move with non-uniform speed? So as you know, non-uniform speed means object covers unequal distances in equal interval of time. So again you look at table 8.1. Distance travelled by B in meter is not uniform. See these numbers are changed. So here the numbers are 12, 19, 23, 35, 37 and 41. Like this. So now we will draw a graph for this data, a distance time graph when object is moving with. This is second one, when object is moving with non-uniform speed. First one was when object is moving with uniform speed. Now here non-uniform speed. Why non-uniform? Because time intervals are fixed. The time intervals are of 15 minutes. And the distances are, you see here the difference of these two distances is 7 meter. Here the difference is 4 meter. Here the difference is I think 12 meter. Here difference is 2 meter. So unequal distances are covered by the object in equal intervals of time. So we will take the distances in a different way now. it starts from 12. So let this is 10. Or you can take the 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. So first at 9:30 am 12. So 9:30 am is this time, and the distance covered by it is 12. 12 is here, 11, and this is 12. This is the first point. Then at 9:45 distance covered is 19. 19 is here. Distance covered is 19 at 9:45 am. Then at 10 am 23. 10 am 23. 23 is here. And then 35. Now if you will join these points, you can complete these points in your copy. So if you will join these points, so graph will be like this, isn't it? Further it will change. So what it shows, that if object moves with non-uniform speed, then graph will be a curved line, isn't it? Graph will be a curved line. A table is also given to represent non-uniform motion on page 104. The time in second and distance in meter is given. Time in second 0, distance 0, time 2 second, distance 1 meter. Table 8.2. You can take this table also and try to draw a graph, and you will find that when object covers unequal distances in equal interval of time, then graph will be a curved line. So you write the conclusion. When object, write these lines. When object is moving with non-uniform speed, when object is moving with non-uniform speed, then distance time graph will be a curved line. Then distance time graph will be a curved line. Now with the help of curve, you can also calculate the speed by drawing a tangent at that point, but that is not in our syllabus, so we will read about it in higher classes, how we can calculate speed when object is moving with non-uniform motion, when object is in non-uniform motion. Now some of the questions we will discuss on page 107. First, what is the nature of distance time graph for uniform and non-uniform motion of an object? So now we have discussed distance time graph will be a straight line if object is moving with uniformly, its motion is uniform, and for non-uniform motion the distance time graph will be a curved line. Now, what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Now, look at this. Suppose a distance time graph is like this. Time we have taken on x-axis and its speed or velocity on distance on y-axis. So according to question, a distance time graph is like this. It is parallel to time axis. So what it shows, from graph we can see the distance covered by the object is fixed, whatever be the time. In the beginning, suppose this distance is 4 kilometers, and suppose time is 0 here, time is suppose 8 am, here 9 am, here 10 am, here 11 am, like this. So this distance is fixed. 4 kilometers at 8 am, 9 am, 10 am, 11, whatever be the time, the distance is fixed, isn't it? So it shows that the body is at rest. So what we can say about the motion of an object whose distance time graph is a straight line parallel to time axis? We say that the object is at rest. Next class we will discuss the next type of graph, that is velocity time graph. These graphs are very important, children. So till then you must revise it. You watch the video carefully and must solve the related questions with some side book also. If I will also give some questions in WhatsApp, I will send some of the questions based on this distance time graph. Thank you.